Okay, so we're going to do kind of a look back at the greatest hits from the first 8 sections of this class. So we started out this course looking at a couple of expressions and equivalent expressions. In the end of the day, I'm not sure that really rises to, being worthy of a test. I've got a lot of questions I'd like to ask. Domain of an expression. We've done a lot of work with domain and range. So the concern with this one is that the denominator not equals 0. Probably multiplication or division of some fractions would be a good one. This one in particular is pretty good because you've got to divide. Now when you divide by a fraction, you have to invert and multiply. The other thing about this one is that this one is challenging to factor. And, there's a couple ways to factor this. There's the guess and check method. There's the AC grouping method. But let me just show you one quick little trick in factoring these things that will work as long as it does factor into something other than a prime. Now, do you want to do the top right one, or the bottom left one? Your choice. Top right. Okay, good choice. So 16x squared plus 16x minus 5. What I'm going to do is I'm going to graph that parabola. So let's graph it in Desmos, of course, because Desmos is going to make this a lot easier. So y equals 16x squared plus 16x, what was it, plus 5? Was it plus 5 or minus 5? It has to be something I've got wrong in there. Minus 5. There we go. So minus 5. And it helps if I can type. All right, so if you take a look, the graph crosses the x-axis at 2 places. One right here and one right there. Let's write down what those 2 places are. So I get 2 solutions. X equals negative 1.25 and x equals 0.25. So let me switch my screens now. Let's write these as fractions. We'll start with the easy one. What's 0.25 as a fraction? 1/4. What's negative 1.25 as a fraction? Negative 5/4. Nice. I was expecting people to go to negative 1 1/4 and then turn it to negative 5/4, but you hit it right away. Excellent. Now, let's multiply both sides by 4 here to get rid of the denominator. I want to clear out that fraction. So I'm going to multiply both sides by 4. On the left-hand side, that gives me 4x. On the right-hand side, I get negative 5. I'll do the same thing for this one over here. I'll multiply this by 4. Can anyone tell me the equation I get now? What would that give me? What equation if I multiply both sides by 4? 4x equals 1. Good. Now I'm going to move the 1 to the other side. When I move the 1 to the other side, it changes signs. So it's 4x minus 1. Over here, if I move the 5 to the other side, I get 4x plus 5. And guess what? Here's my factorization. So it's going to be 4x plus 5 times 4x minus 1. And that would be your 16x squared plus 16x minus 5. Wow. That's pretty cool. Desmos rocks. Love that stuff. All right. So, that's the big chore in working on a problem like the one I just had up there, is factoring it. It's a pain unless you're clever. And there's nothing wrong with being clever, especially if your instructor is letting you use Desmos on that special phone app. All right. Complex fractions, probably a good choice on that one. There's a good possibility you get something there. Let's see. Is there anything else? I think there's other stuff here in this one. These two, adding and subtracting, rational expressions, you need to get common denominators. I put something out there. I did come up with a different way to work on something like these last two. Now these last two I do like, not because I'm mean, not because I want to make you work hard, but because you're going to see these again in calculus. And I want you to be able to do them. I want you to just say, oh yeah, I got this one. So I'll give you a choice. You want to do the first one or the second one? Doesn't matter to me. First one? All right. So let's do the first one. So let me copy that down. It's going to be 6 times 8 plus x to the 1/2 minus x times 8 plus x to the negative 1/2 over 8 plus x. Now I'm going to remind you of a couple things as we do this one. So that's here. Let me just put this off to the side here. I want you to recall, let's see, that when you multiply two things with the same base, what happens with their exponents? They add. You have the same base, but you add the exponents. So beautiful. Now what we're going to do different this time than we did the last time is I'm going to notice that I've got a negative exponent here. And that's the second thing that I'm going to ask you to recall. If I add a to some negative power, I can write that as 1 over a to the positive power. So that's what I'm going to do with this term here. Now it's just the 8 plus x term that I'm going to put in the denominator. So I'll write this as 6 times 8 plus x to the 1/2 minus x is going to stay in the numerator over 8 plus x to the 1/2 over 8 plus x. So all I did in this first step was I took this term and put it into the denominator. Nothing like that happened with our first term. But for convenience, I'm just going to write that over 1, just to have something there to look at. This is a complex fraction. And the way you can simplify a complex fraction is to get rid of these secondary fractions. So how could I do that? If I wanted to just get rid of this from the denominator, I would multiply by that denominator, or the lowest common denominator. So here's what we're going to do. I'm going to multiply the numerator and denominator by that term, by that LCD. And I've kind of run out of room here, so I'm just going to rewrite it up here. 6 times 8 plus x to the 1/2 over 1 minus x, 8 plus x to the 1/2 over 8 plus x. I'll write that over 1 as well. I'm going to multiply the numerator and denominator by this term here. 8 plus x to the 1/2. 8 plus x to the 1/2. Now, I don't want to cancel these things. What I want to do instead is I want to multiply this times this and this times this. In other words, this term is going to have to distribute itself to both of those terms in the numerator. This times this, this times this. You want to work with the easy part first? Let's work with the easy part first. In the denominator, these things have the same base. It's 8 plus x to the 1/2 power times 8 plus x to the first power. When you multiply things with the same base, their exponents add. So in the denominator, I'll get 8 plus x to the 1 and a half power. 1 plus 1/2, 1 1/2. All right, good. So we're done with the denominator. You don't have to worry about it anymore. How about the numerator? Let me start with the second part here. When this multiplies this, let me kind of write it off to the side. I got 8 plus x to the 1/2 times x over 8 plus x to the 1/2. Those terms are going to cancel. The only thing that's going to be left is the x. Okay, that's great. Is there any cancellation here? No, because I've got a denominator of 1. It's not going to cancel with anything. But here, just like the denominator, the exponents are going to add. What am I going to get when I add 1/2 plus 1/2? What's 1/2 plus 1/2? X. So we get x plus 8 to the first power. Wow, that's nice. Do I need to write to the first power? That's just kind of understood, right? Let's get rid of that. You're almost home. Distribute the 6. I get 48 plus 6x minus x. And I'll write that as 8 plus x to the 3/2 power. If you combine like terms, you get 48 plus 5x over 8 plus x to the 3/2 power. Whew. Not pretty. Maybe a little bit easier than the way I did it the other day. It's up to you. Whatever method you choose, whatever you find convenient, that's fine with me. All right. Let's look at some more here. Kind of hitting the highlights. I think that's it for section 1.4. Section 1.6 are inequalities. Probably a nonlinear one, maybe something like this. This is the ones where you tested some points. This is the same thing, except you got a factor. The nonlinear inequalities like this one, these are rational inequalities. You've got to write something like this with one term first. So you'd have to get common denominators and write it like this, and then do your testing of points. Absolute value inequalities. The thing about the absolute value inequality here is that you've got to start by solving for the absolute value first. So I got to subtract 3 from both sides and then divide out the negative. And then some of these, I might have you reverse engineer. Let's see, section 1.8. Actually, that was 1.8. We missed 1.6, didn't we? No. Did I get 1.6 twice? Complex numbers was in here someplace. I thought complex numbers was 1.6. Yeah, something happened to that. Complex numbers, you should expect powers of I. Add, subtract, multiply, and divide. Complex numbers, but definitely powers of I. Remember stuff like that we did? We did I to the 32nd power, I to the 33rd power, those kind of things. So that's what I mean by powers of I. I to the 94th, I to the 638th power. Those kind of things. You can check that stuff on your graphing calculator. I have no problem with that. You just need to show me some justification for your answer, other than, gee, that's what my calculator told me. All right, that's not what I'm looking for. Section 2.1, you should be able to graph and or work with piecewise functions. Domain and range, we talked about that a little bit. This stuff, we just practiced that tonight. That's a good one. Now, I can't put everything on there. I know that. The test will be reasonable, and I do give partial credit, but I do ask that you show your work. It's probably reasonable to ask you to graph a piecewise function. You can either use Desmos or your graphing calculator. Let's see. Section 2.3, we talked about domain and range. We talked about increasing and decreasing. Remember, increasing and decreasing are going to be intervals along the x-axis. Section 2.4, average rate of change of a function, net rate of change. The net rate of change is just the difference in the y-coordinates. The average rate of change is the difference in the y-coordinates divided by the difference in the x-coordinates. Basically, the slope. I would probably expect something like this right here. We did this for an example. This one would be a good example. This one's a little bit hard for a test. It'd be really nice if you could understand these ideas about increasing at a constant rate, increasing at an increasing rate, and increasing at a decreasing rate. That might be a little bit tough, but if you could, that'd be awesome. Maybe you want to explain how these 3 different racers ran the race. And last but not least is a couple easy ones on linear functions. The average rate of change of a linear function, of course, is just the slope of a line. So the average rate of change here would be -1/3. You should be able to create a linear function based on a table. That, just looking at now, feels like a good problem. And then maybe interpret the slope of a line as it applies to a problem. So anyways, I hope that gives you a real good idea about what to expect and get ready for next week. The test will be at the start of class, so make sure you're here on time. The test is not on Zoom, so please show up in person. Any comments or questions?